question 1, on the Venn diagram question. Now then, these are the 4 equations really that come into play. Now, we can always use these first 2 equations. There's no condition needed to be mentioned in the question to be able to use either of those first 2 equations. You can only use this third equation if you're told that A and B are mutually exclusive, and you can only use the final equation here if you're told that A and B are independent. Okay, so when I read the question there, I don't see anything mentioned there about mutually exclusive or independent, so I'm not able to use either of the last 2 equations. So I'm down to using these first 2 equations. Okay, so I'm told probability of A is 0.2, probability of B is 0.6, and the probability of A given B is 0.3. So the equation that's going to kickstart this question is by using the second equation here, the probability of A given B. Okay, so the probability of A given B, I replace the line with the intersection, A intersection B divided by the probability of B. And I substitute in, probability of A given B is 0.3. Intersection I'm not given, and the probability of B is 0.6. So to get the intersection, I take the 0.6 to the side and I change it from a divide to a times. So 0.6 times 0.3 is the probability of A intersection B, and 0.6 times 0.3 is 0.18. So A intersection B is equal to 0.18, and that's what was asked for part A. Now, because I got the intersection, I got A and B, I can now complete the Venn diagram for this question. So I'll draw in 2 circles. And then rectangle contains all the probability. Okay, so that as a value of 1 is A, there's B. Whenever you put the Venn diagram in, you always start with intersection. So A intersection B is 0.18. So it goes in there. Now the probability of A is 0.2. I've used up 0.18. So the whole A circle has to be 0.2, so that must be 0.02, subtracting 0.18 from 0.2. And B is 0.6, so all that circle is 0.6. I've used up 0.18, so subtract 0.18 from 0.6, and that gives me 0.42. And then to get the value outside, I add these 3 values up and take it away from 1. So 0.02 and 0.18, that's 0.2, and 0.42 is 0.62, and then take 0.62 away from 1, and that's 0.38. So part B wants the probability of B given A, so I replace the given with an intersection, so that's B intersection A divided by the probability of the second one, which is A. So B intersection A is the same as A intersection B, so that's 0.18 divided by the probability of A, which is 0.2. So divide in those together, and I got 0.18 divided by 0.2, and that gives me 0.9. Part C, A union B, probability of A union B. A union B are these 3 values added up. So it's 0.02 plus 0.18 plus 0.42, and adding those up gives me 0.62. And finally part D, probability of A dashed intersection B dashed. So that means it's got to be outside of A. So there's the A circle. Outside the A circle are those two values, 0.42, 0.38. And also it's got to be outside of B. So outside of B is 0.02 and 0.38. And the value that I saw twice is the 0.38.